Problem 3. Three-phase star and neutral, unbalanced load. Okay, so this time, got a load from previous problems now changed so that the load is unbalanced as follows. Phase 1, say the red phase if you like, 1950 ohms connected to it, so the same as before. But the yellow or phase 2, 950 ohms, and the blue phase 3, 3770 ohms. So still connected in star to a three-phase neutral generator, line voltage of 300 volts. Determine the new current flowing in each load, the new current flowing in the neutral conductor. Okay, so I think with the practice we've already done, have a go at that problem, and then when we think everybody's had a reasonable go at it, we will review and go through it on the board. Right, so three-phase star and neutral unbalanced load. The first thing really, as always, is to draw some kind of diagram of the system. So we got 1950. Yellow is there. That was 950, wasn't it? Blue 3770. We got a neutral off the middle, IN, and we got red, yellow, and blue. And that gives us an IR we've got to calculate, an IY, and an IB, and all of these are 300 volts. Yep, all happy with that? That's what the question says. Yeah, and you've been asked to calculate I believe the currents, wasn't it? New line current in each load, new current in the neutral conductor. So we're going to start with IR. How do we calculate that? Yeah, so it's E line, E red over root 3 divided by R1. What do I really need to add to that voltage? For completeness. Angle 0 degrees. Yeah? What does that come out to? Yeah, we all put the values in, didn't we? 300 over root 3 angle 0 degrees over 1950 equals yeah, like before, exactly the same as before. So that hasn't changed because that's the same load as we had before. For reference, stays the same. IY that must be EY over root 3 angle 120 degrees over 950, or R2 I should put for completeness. That's 300 over root 3, angle 120 degrees, over 950 equals 182 milliamps, angle 120 degrees. And lastly, IB must be EB over root 3, angle minus 120 over R3. That's 300 over root 3, angle minus 120 over 3770, comes out at 45.9 milliamps, angle minus 120 degrees. So now we've learnt that lesson from the previous problem. We know if we're going to be calculating this neutral current, you must, if you're going to add or subtract, you must include the full complex value to get the right result. Yep. Okay. There's a balance between when you need to know and when you're just talking about, when you just want to know the magnitude, the size of the current you're going to measure, you're not particularly worried. But because we're adding three currents together to get a resultant current, we've got to take the angles into account. Alright? There are no daft questions, Tom. Yeah. I try to distinguish between the voltage that is from a source, like a battery or a generator, i.e. an EMF, an applied force, as opposed to a voltage drop across a load, which I would use V as the terminology for normally. However, on these diagrams, I did use E phase because that is also an applied thing as well. Once you include the neutral, you've got a phase applied voltage that is root 3 of the line voltage. Yeah? Okay? So generally, when I'm talking about what comes from a battery, a generator, I'm trying as consistently as I can on the degree to use E for that applied voltage for EMF, and then use V's for volt drops across resistors and things like that. Alright? Yeah? So, part B, 5 kCl, IN is I1 plus I2 plus I3. We know, I've used red, yellow, blue to indicate them earlier, so it must be consistent. Okay, but we've got to have them in rectangular values, so just put a note here, convert currents to rectangular. That's what we need to do. So IR, which was 88.8 milliamps, angle 0 degrees, that in Cartesian must be what it was before, 88.8 plus 0J. Yeah, I'm right. I yellow, which was 182 milliamps, angle 120 degrees. Would that come out at in Cartesian? Rectangular, whatever we call it. Minus plus 158J, and IB was 45.9 milliamps, angle minus 120 In Cartesian, that come out as which is 23.0, Danny, and if we round it to J. Yeah. We then add them all up. What do we get? All agree with that within reason? Yeah. And that convert back to polar. 121 milliamps, angle 102 degrees. Yeah? All right with that? Yeah.